Hello guys, today we will discuss this question. This question came in CSIR NET 2019 December. Okay, and this is the question on the screen, and you can see this is the diode associated with these two reagents. So this is the reagent 1 and reagent 2 to form the product A and B. And this is the structure of the A and B is given. Which one is the correct structure of the A and B we have to predict. So guys, let's start. To see this reaction condition, we understand this reaction is actually a named reaction, and the reaction is known as Carbene-Winter olefin synthesis. So guys, this reaction name is Carbene-Winter olefin synthesis. Okay. So in this reaction, a particular mechanism is there. So what is the mechanism? So before coming to the mechanism, I want to see this stereochemistry of this reactant. So if you see this stereochemistry, we can write it like this. So this OH will be in the above the plane and hydrogen will be there in the below the plane, and this OH will be also above the plane, and here hydrogen is there in the below the plane, and this will be like this. So therefore this is a trans, this C2H5 and this C2H5 are in the trans to each other. So therefore whatever the product we will get from this, we will get a trans product. Okay. So guys, here we can see, to better understanding, I am rotating this bond, and this OH will come to the position of the C2H5, and C2H5 will come to the position of this hydrogen, and this hydrogen will come to the position of this OH. And this solution does not change the stereochemistry of this reactant, and hence it will equivalent. So guys, it will form like this. So this is the OH like this, and here this will be like this OH, and so this will come in the below the plane like this, and this hydrogen will come to the above the plane. So guys, this will form, and these two are actually equivalent. So now this one is related with this one, and here we can see, we can write it like this. This IND is representing the imidazole ring, and this is actually the structure of the imidazole ring, and this is very good leaving group. Why it is very good leaving group? If this bond will break and the negative charge will come on this nitrogen, this negative charge can be neutral. This negative charge can be stabilized through the resonance, right? Throughout this ring, and the resonance stability will make this elimination of this group will be more favorable. And you can see that will be a aromatic structure as well. So therefore, whatever the group which will leave, that will get the aromaticity, and hence it will act as a very good leaving group. So therefore, now these oxygens are there which has lone pair, and this oxygen can attach to this electrophilic carbon, and then what will happen? This bond will open up and again close, and one imidazole group will come out. So what will form? So I just do a step jump here, and I will write it like this here. Okay. So this double bond S will form, and imidazole will be there, and one imidazole minus will come out. And you can see here, and another oxygen is there. So this oxygen will do the second nucleophilic attack on this electrophilic carbon, and this will open up, this will close, and this imidazole group will remove. So what will form? A 5-membered ring will form. So again I am doing this step jump to show the 5-membered ring here. So you can see this will form. Okay. Now this is the 5-membered ring. This intermediate will form. This will treated with this POMe3. So POMe3. So guys, the phosphorus has the lone pair, we know, and this lone pair will search for electrophilic position to attack. So there are three chances: either this center or this center, these two are equivalent, or this center or this center. If we have to this center, then what will happen? This bond will open up, and this will come here, and this will open up, and S minus will form. And so therefore this is stabilized. And if it is added to here, then it will open up this S minus, and again it will close, and the O minus will form. So guys, this may attack to here or here, or it may attack to sulfur directly, because sulfur has the vacant d orbital, where it can accept the electrons coming from the phosphorus, right? So therefore, there are three chances. Why the phosphorus will attack? It will. So we know the phosphorus is a third pair element, and this sulfur also third pair element. So therefore, this attack will more favorable because of the orbital overlap is much better in case of the sulfur and phosphorus, because both are the third pair element. But carbon is second pair element, and hence the carbon has the orbital has a lower size, and therefore the overlap integral will be very less. So therefore it will not choose the carbon. This phosphorus will choose the sulfur to attack, and hence a negative charge will come on this carbon. Okay, so this intermediate will form. So this is the hydrogen, this is the O, and here this is like this, and here this is O, and this is the hydrogen, and this will be like this, and here you can see this sulfur attached with this phosphorus ONe3, and this phosphorus will be have a positive charge, because positive charge is because this will give its lone pair, right? And a negative charge will come on this carbon. So this will be the intermediate. Now what will happen? This sulfur has a lone pair on it, right? And this lone pair will neutralize the positive charge on the phosphorus by donating the lone pair electron to the phosphorus vacant d orbital. And after that, the sulfur will get a positive charge because sulfur will give its lone pair. So to reduce this positive charge, this bond will break, this carbon-sulfur bond will break, and the bonding electron will transfer to the sulfur. So therefore, a positive charge will come on this carbon, and this carbon is already having a negative charge. So the same carbon having a positive charge and negative charge is known as a carbene. So therefore, a carbene intermediate will form. So guys, here what will happen? So one byproduct will eliminate here. So this is the byproduct. Okay, OAB whole 3, and here one carbene will form. So this is the structure of the carbene. So this is the hydrogen, and here this is like this, and this will be like this, and this will be the hydrogen. So guys, this is the carbene. This carbene is actually, we can write it like this: a vacant p orbital is there in it, and one more p orbital is there with 2 electrons in it, right? So carbene is actually having this type of structure, and this carbene is actually stabilized by the oxygen lone pair, the oxygen present adjacent to it. So this oxygen lone pair will stabilize this carbene. How it is stabilized? This oxygen lone pair will give the electron to the vacant p orbital of this carbene, and this carbene electron will come like this, and this bond will break, and this will come here, and this will again neutralize this oxygen. So in this way the electron will rotate. Okay, and what will form? This will be form a carbon dioxide, and here a olefination will take place. Okay, so guys, here you can see there will be another byproduct, that is the carbon dioxide, and here olefin will form, and here you can see these 2 hydrogen are in the trans to each other, right? So this olefin will form where one hydrogen will be like this, and another hydrogen will be like this, and therefore this will be like this, and this will be like this. So this is the E isomer. Okay, so this is the trans isomer. E isomer will form, right? So guys, if you see this option, in this option, the option number 3 and option number 4, the cis will form. That means the Z isomer was formed, but actually this is not the correct structure of the product, because product will be E isomer. So therefore this is not the correct. So 3 and 4 is not the correct. Now among this 1 and 2, if you see the byproduct, then it is the CO2, not the C double bond O double bond base. So therefore this is not the actual byproduct. So therefore this option number 2 is also wrong. So option number 1 is showing everything right. So therefore option number 1 is actually the correct answer. So hope guys you understand this mechanism. Thank you so much for watching this video. I will come for the next video tomorrow. Please like, comment and subscribe my channel. Thank you so much.